Hello y'all, welcome back. Thank you for clicking on today's video. Today we're doing our second example of an independent t-test, and this time I'm actually going to do it using R, and then I'm going to fill in all of these parts of Fred after we get our analysis from R. So we are looking to see if GVSU students who ride the bus study more than GVSU students who do not ride the bus. So one of the key things that you want to focus on here is the word more. That means that our alternative is going to have a direction to it. It's not going to be a two-tailed test, which is the not equals. Here we actually want to see if one group is bigger than another group. So right now we don't have our groups decided. So let's pop into R, and here you'll notice that I have some code that we've used before to do our reviewing of conditions. And this first one is the t-test, which is going to do basically the whole executing calculations for us. And so when you do this, you want your first variable to be the response variable, and then the second variable is the explanatory variable. So technically what that would look like is the quantitative variable that you want to compare is going to be the response variable. So here would be study time, and then the explanatory variable is the grouping variable. So here it's yes, they ride the bus, no, they don't ride the bus. So essentially we're saying we think that riding the bus would explain how much study time, and that's how it gets the explanatory response terminology. So here I'm going to take this output. This is after doing the t-test, study, and then a tilde with the bus. So remember, that's our explanatory, our data, and then we're doing a 95% confidence interval, but we won't talk about confidence intervals until future videos. And so here, I'm going to pop this right into the top, and I just want to show you a few aspects of it. So one, it's telling you that it's doing a not equal to, which means that the analysis it did is a two-tailed test. So we'll deal with that in a minute. It's telling you degrees of freedom, which is nice because it's doing that long calculation for us, and it's giving our test statistic. One thing that you don't notice is it doesn't tell you how the groups were calculated, meaning the differences, if it's yes minus no or no minus yes. So it is alphabetical, and you can verify that by showing the mean is 3.14 for the no's and 3.16 for the yes. And because the test statistic is negative, that does indicate to me that group 1 is going to be the no group. So I'm going to highlight that. The no's are the green because it will help us to remember which group is which. See, I almost started getting confused. I don't want that. And then this is the do not ride the bus. Alrighty. And then those who ride the bus are going to be the yellows. So yellow, oopsies, it's going to be this and this. Okay, so that means my group 1 is those who do not ride the bus, and then group 2 is going to be those who do ride the bus. So this is the do not, and this is the do. And that means that mu1 would be do not, and this would be the do. So with this then, if I go back to my R, I can run my sample size, and for the no group I have 774, and for the yes group I have 1460. So here 774, and for the yes group I have 1460. Now here I want to show that the do's are more than the do nots, but my yes group is the second group, and so this would be a greater than on that side. because my first group is the do not, and I think they study less than the do.